in the field building homes. Oh, we're getting recorded. Got it. Both of us have worked in the field building homes for most of our lives. So we always like to tell everybody that the things we're talking about in these workshops that we do, no one's a guinea pig. We have done most of the things that we're going to talk about here, and most of the photos are from my job sites or sites that Jennifer has worked on, sites we have currently under construction. And we also hope that this gets treated like a conversation. So we don't want to just try to give you information. This is kind of a broad overview of the benefits of higher performance, and we use the suffix ER there because we're not really talking about crazy stuff. We're not talking about 14-inch thick walls and windows with an R12 that you need in the Northeast Kingdom. We're just talking about slightly better windows and slightly better construction. So feel free to put questions in the chat, during the program, and Itzel's going to monitor the chat. I think Jennifer can see it too. I can't see it, and I can't see who's in the program. To that, if you'd also drop us a line and say where you are and what you do, if you're an architect, if you're an engineer, if you're a builder. It's probably tough to get builders in anything during the day right now because everyone's so busy, but if you're an architect or an engineer, let us know. It's good to have the engineers here. So today's objectives: identify strategies for selecting and locating windows. This is for the AIA credits. Learn latest window and glass technologies, be able to incorporate detailing and specifications for the higher performance envelope, understand some operability options and impacts on ventilation and indoor air quality. Get that slide out of the way. This is the path we're going to try to follow today. We'll try to go through it as quickly as we can. We love to talk about this stuff and kind of get squirreled often by a question and tend to go down a rabbit hole. So we'll try to move as quickly as you can and then leave some good time for discussion at the end. But we'll start with an overview, real brief. What the hell are windows? What are the advantages they have for us? What are the disadvantages? Some of the properties of these different frames available to us now. We're in a pretty dynamic industry. I mean, I'm in the field every day and talking to distributors multiple times a day. And I feel like every time I talk to them, somebody's got a new thing that's just come out that's the greatest thing. So it's tough to keep on top of it. Glazing options, again, changing every day. We are not product centric. None of this is sponsored. That's why we use our own photos in most of these projects. But we do talk about some brands. That word is terrible. Brands and products. Alpin is doing some amazing stuff with glazing, with American-made windows and glazing right now. So we talk a little bit about them, and then we wrap it up with some specialty sections here. So windows, let daylight in, keep weather out. That was the main intention in the beginning. Longer story and some of the things that we can actually make our homes, work for us. It doesn't have to be a detrimental process from the moment we put them in to when they fail. We can use all of these things to our advantage to keep the curve on our performance graph going up rather than depreciating over the lifetime of the home. So lower energy bills, no moisture problems. That has a lot to do with the detailing of installations. No condensation issues, and it will show you how manufacturers are starting to catch on to that. And there's actually a condensation rating on window labels now. Consistent comfort. A window is essentially a large hole in the wall of a building that we try to compensate for in some way. We want that light to come in, and then we put something in there to give it some kind of deterrent from the outside to the inside. So we're building, R20 to R30 walls, and then we're putting a window in there that's like an R2. So it's essentially a giant hole in your wall. So we're going to try to stop doing that. Resiliency in the face of change. Windows play a big factor in fires, actually, and the resiliency of a home during fires.
Yeah, windows, are also a component. They're part, how I like to say it is they're a part of the energy puzzle as California heads towards carbon neutrality. And we've set that goal to hit that carbon neutrality in 2045. So a great resource, I think, for a lot of architects and all, but also you share with your, oh, hey, there is going to be a, yes, I see a question in the chat. I'm so excited,
Girl.
someone's using the chat. Okay. Yes, it tells me there's people out there. Because like Mike, when we're in presenter mode, I can't actually see everybody's faces, but I can see the chat. So yes, there's a question about condensation rating. Yeah, we'll hit on that in just a moment. But just kind of maybe bigger picture overview of where windows fit into this big picture of why the 3C REN is working on windows as part of our overall picture for California and energy reduction and low carbon future for California, is that windows can be chosen so that they reduce peak loads in heating and cooling, which also translate into greater comfort for your clients. And these windows can also play a really strong part in moving new construction to needing less fossil fuels or moving to an all-electric home and have it be comfortable and energy efficient. And that's because the windows have new, there's some new products and technologies available, readily available, that you can start to use in the homes. So Zero Net Energy Cookbook, that resource is, I really recommend it. This is a picture taken from Edison, utility company, edison.com. And the only thing we would probably modify or update on this drawing is where it says ceiling fans. We'd add ERV or HRV for energy recovery or heat recovery ventilation. Otherwise, like, that's a great diagram and a great resource. I'm going to hand it back to Mike.
I was just thinking as you realized a question was coming in about the condensation rating. So we use a mantra. I'm like beat it into people's brains while we're working. Every day is a school day. I probably say that 25 times a day. I've been building since I was 16, 17 years old. Jennifer and I both worked in this field forever. And every day is a question that comes up and then an answer that we try to work our way through. So we didn't learn about condensation rating until we started putting this together a couple of months ago and realized that that's something that's offered now. So so this is our cohesive systems approach. If you've been in workshops with us before, or on another note, if any of you have done any kind of passive house certifications or done any of the workshops, and 3C REN was offering the passive house workshop, I am PHI certified as a passive house designer. I've also done the FIAS training, and Hannah in our office is PHI and FIAS certified. One of the few people in America to be certified with both. These are actually the 5 strategies of passive house, and though that's not what the workshop is on, it is a fantastic way to look at a cohesive system approach to a building, whether or not you are going for some kind of certification or just want to build a better performing home, a healthy home, a home that doesn't depreciate from the day you hand over the keys. So the 5 strategies of passive house are all greatly affected by the windows. The windows play a huge role in passive house construction. And even if you're not certifying, they play a great role in the interior comfort of a home that's not even going to be a passive house, but might just be a pretty good house. So today, this is a broad overview. We only have an hour to talk about windows, and some of us have been talking about windows for 25 years. So we're going to squeeze it into this little section and hopefully have questions at the end. So we're going to focus on just these two sections here. We are not going to talk about curtain wall systems used on larger buildings. That could be a whole nother conversation. There's often the idea that you know, the tree hugger, greenie builders are pushing things that are beyond the limits of average builders or average architects. The first time I installed high performance windows, I remember the very first one that arrived at a job site and the amount of homework that we did, learning how to do the install, and the amount of worry I had the night before, and the amount of stress that the crew had as the first one came off the crate. And then we put it in the window opening and said, oh, that's pretty much the same as every window we've ever installed ever. So this is going to be a piece of cake. There are a few little nuances, but we're trying to switch our lexicon, our language from sustainable, resilient, and green to just responsible. You know, these are things that we should be doing for our clients. There are fiscal advantages for our clients. We don't have to sell this to them. These are not things that are more expensive. You could compare it to a car. You know, a client might say, well, what's a good window cost? And you can say, well, what's a good car cost? I don't know. A good car to me is a Prius. A good car to my client might be a Bentley. So there are Bentley windows available. There are really good Prius windows available too. So we're trying to shift our lexicon towards responsible design. So we're going to use the label on our windows to drive the next few slides, and Jennifer is going to walk us through this label, what these properties mean, and some of the additional properties that are starting to come into play as well. So I've been building forever and never really paid much attention to the entire label and what it meant. So this is a good practice for even somebody who reads these all the time to go through.
You're brave for admitting those things, but I think that's just true with our industry. Like, we have the folks who understand the science behind all of it, and it is important that the windows are labeled. And then there's like it's our industry, we expect folks to then sort of learn this stuff through osmosis, right? And we expect the guys on the job site just to learn what a NFRC label is, because now they're on a job site installing windows, or maybe doing the flashing around the windows. But we're big advocates of realizing that we need to talk about all this amongst ourselves, you know, to other architects, to the engineers, and to builders, so they will actually know what these things are. So in case you're not that familiar with those labels, they do go through something called a U factor, and then we go into visible light transmittance, and we go into solar heat gain coefficient and air leakage. Those are kind of the four main metrics that were used for windows. Probably the easiest one to understand right away is visible light transmittance, and it's basically a percentage. So if you have a 1.0, 100% of the visible light spectrum is coming through that glass. And most glass is going to be around 0.5, that are most of those windows are going to be like cut out half the visible light. It's like putting on a really light pair of sunglasses. And then when we look at the window as a whole unit, and so what I tried to illustrate here is a section through a dual pane window with a low E coating, and showing the frame at the bottom. The U value, and often called U factor, they're same term, just been used back and forth over the years. That takes into account all the transfer of energy through that frame and glass. So that could include the heat that comes through the glass itself and the heat that comes through the frame itself. And then just to give you a little reminder on the right, the solar spectrum, that all the energy that we get from the sun, there's just a small range of wavelengths that are visible light, is the wavelengths that our eyes are sensitive to and perceive and send a signal to our brain. And then there's all the other parts of sunlight that comes through, including infrared and UV. So you know that from getting a sunburn or from feeling the heat of the sun on your body. Your eyes don't necessarily pick that up, but our skin does. And then there's a lot of other wavelengths that our body doesn't sense, but it still comes through the glass nonetheless and affects the energy heat gain through that whole unit. And Mike, feel free to jump in on any of this too, you know, as if I missed something or skipped something. Mike and I often go back and forth as a dialogue on all this.
Sometimes the U factor conversation reminds me of, I don't know if people, we've been doing these workshops for almost 3 years now. So if some people were in some of the earlier ones, we have a slide showing how an average San Luis Obispo day where it was 72 degrees outside, I had a brand new apartment downtown in downtown SLO overlooking, you know, the mountains that faced west. So I had this large window that faced west, and on a 71, 72 degree day, as the sun set in the west, the interior side of my window was 96 degrees, even though the exterior temperature is 72 degrees. So a bad window, you are inadvertently building a furnace inside the home or apartment that you're building, because the thermal transfer is so high that even as the sun sets in the afternoon, the interior side of the window is cooking. So the sun's baking those frames or that glass, and you can feel it. We use a laser temperature gauge to actually collect it, but that's what we're talking about with U factors.
Hey, Mike, gonna interrupt really quickly. A question came in from Chie. I'm hoping I'm pronouncing their name right, but
Chie,
yeah. Can you please give the definition for U factor versus U value?
Yes. So U factor and U value are the exact same metric, same number. So for a long time, the building scientists and window industry used the word U factor, and then they became more fashionable to use U value. And now I see when I go through all the literature, depending on what part of the country, depending on what sort of generational age the person is who's doing the authorship, they'll use either U value or U factor, but they're the exact same metric.
And it pertains to basically the R value. So I think I feel like the newer generation coming up has just simplified it and said, why are we using two different words? So.
Right, and then, yeah, numerically, like a R value, 1 over the R value would equal the U value, or the U value, you know, or vice versa. They're inversely related to each other. So if you're used to thinking of R value like bigger, better, same with the windows, we want bigger, better. But on U value, since it's an inverse, we want lower, better. You know, so lower U value equals bigger R value, which I know from teaching like building science classes at Cal Poly, that sometimes is hard to keep straight. If you're new to this, it's sometimes confusing. I get that.
It's the opposite of keeping it simple.
Yeah, right. But we had a bunch of math people doing all this early on. So anyhow, now solar heat gain coefficient, this is slightly different in that this is a property of the glass itself, not the overall frame. Well, let me back up. It is a property of the glass itself. It also does include shading from the frame when we look at it for a whole window. But this solar heat gain coefficient is really specifically looking at how much extra heat that our eyes don't see can come, or how much of the wavelengths from sunlight can come through the glass that our eyes are not perceiving versus, how much can be blocked out by special coatings, low E coatings. And the low E stands for low emissivity, and the emissivity refers to what's going on with the wavelengths of the sun. So this graph, for those of you who like and read graphs, the red line, the solid red line up at the top, represents clear plate glass. And clear plate glass allows almost 100% of the visible light in, not around 90% of most of the visible light, but it still blocks out some infrared heat, some of the unwanted heat. Some of it is absorbed into the glass itself, and some of it's allowed to pass and transmit through the glass. These special low E coatings can still allow a large amount of visible light through, but it blocks out all that unwanted infrared heat that we don't want. And so this solar heat gain coefficient, in effect, a low number, like a 0.2, for example, would be indicative of a window that could still allow in maybe 60%, maybe 80% of the visible light, but block out almost 20% of some of the wavelengths that are in the infrared heat category. Now,
so Jennifer,
yeah,
we're halfway through time, and we're halfway through the TED Talk. So I'm just going to ask a question that people often ask here.
Yeah.
And we don't rehearse these. This isn't like we met earlier and I said, hey, Jennifer, I'm going to ask you a question. And we try to make it look like I'm just asking. But people ask this. So the question is going to be, well, what's better? What are we supposed to use? Low solar heat gain coefficient or a higher solar heat gain coefficient? Like, just tell us which one to use. What should we use?
You're so right. So, okay. So in my perfect world imagination, I think that if I explain this stuff to you, you guys are going to be like, oh yeah, now I know which glass to use. Okay, no, time out. So
we don't have that much time.
You don't have that much time. So you're going to want to work with your energy consultant and your Title 24 consultant. And I highly recommend that you have someone try some different glass types for you, not just go, oh, here's a passing score. We're going to look at a chart that's going to give you a guideline on that. It's coming up.
Yeah, long story made short, there is no, okay, just use this. It depends on a multitude of factors in this whole cohesive system that you're trying to put together.
Yeah, but there's some rules with them. So the other, just kind of a code related thing real quick, is that there's really only two things about the windows that are mandatory under the energy code, and it has to do with air leakage. And the first part of that, the window manufacturer takes care of. And the second part, which has to deal with limiting air leakage around all the joints and connections, actually falls upon the builder to do. So from an architect's perspective, we don't have to worry about this too much, but the builder is actually supposed to take care of a lot of the air leakage. Next slide.
And that pertains to the other sentient beings in our homes. So our pet doors are also supposed to be airtight. Otherwise, it is literally a hole in your wall for temperatures and environments to commingle and move through each other. So there is actually a Title 24 certified pet door that we are supposed to be using on our projects. And this is a picture of the one we installed in a passive house here in San Luis Obispo. No different than your average pet door. It does have a small magnetic strip on one side. So, you know, easily pushed open by even a little tiny dog, but it does actually create an air seal. So environments don't mix right at that location.
Right. And on the on the previous slide there, and I think it's so folks can get a copy of the slide deck, right? Yeah, there's
Yeah, that's correct.
yeah, good. I mean, a lot of the house wrap manufacturers now are providing details in their brochures on their website for how to flash all these windows and doors. There for the builders, there for the architects to use in their drawings so that they do comply with the air leakage part of it. And then back to the label, that kind of hit on those 4 aspects of what's on that label. And then there's the new voluntary condensation resistance metric that also can be used. And I think Mike you have a couple of things to say about this one, right?
Yeah, so this metric is it's voluntary. So manufacturers do not have to put this on the label, but it is starting to show up, and it's a scale of from 0 to 100. The higher the number, the higher resistance to condensation. The lower the number, the lower resistance. I don't know if anyone's ever heard the phrase ceteris paribus, but it means, you know, all else being equal, that's what those numbers should tell us. Jennifer and I are both a little skeptical of this number. It seems like there are so many factors at play to what creates condensation on interiors or exteriors of windows. But I think it shows that they're at least starting to think about it and recognizing that architects and builders are paying attention to the fact that condensation, is a big problem for us. So it's nice to see it showing up a little bit.
Yeah, and I think it's probably going to be more critical for colder climates for that number, for folks to really pay attention to that number. This chart here, this just kind of gives folks an idea of what's in our energy code right now. And when you do that energy modeling, when you talk to your energy modeler for residential or low-rise residential projects, to answer Mike's question on, well, what solar heat gain coefficient is appropriate, it actually depends on the climate zone. And it's not that you have to match these numbers, it's that this is what's going to be used as a baseline for your project. So a low solar heat gain coefficient, 0.23, the state has said makes sense for climate zones 2, 4, and 6 through 15. So that includes North County, San Luis Obispo, parts of Santa Barbara, and a lot of Ventura County would have a solar heat gain coefficient and U factor kind of specified for them. And then up here in San Luis Obispo, where Mike and I are right now, climate zone 5, there is no limit on the solar heat gain coefficient. So that's really where we do a work with our clients to help them figure out what that number should be, because that can have a big, sometimes an adverse impact. Like if we want solar heat gain in the winter, if we choose a window that has a very low number, like a 0.2, we're eliminating heat. But we can choose a really, really, really low U value to compensate for that low solar heat gain coefficient. Go to a triple pane unit, which we're going to talk about in a minute. non-residential windows, it's based on the type, not based on your climate zone. So for non-res, you really want to work with your Title 24 and your, energy consultants on that, because there's no real guidelines based on climate zone. Okay, next, the other property of glass that's becoming more and more important is sound transmission, especially outdoor, indoor transmission class, so OITC. So again, looking lower number, in this case, looking for a number that is meeting a certain threshold. That is a Cal Green code requirement for certain projects if they're in what's considered to be a high noise area, like near freeways or airports. And one of the ways they're getting these lower numbers, or rather a number that's allowing less sound to go through, is a thicker piece of glass in a 2-pane assembly. One piece is thicker, one piece is thinner, and then that way they don't have a resonant frequency.
I don't know if any of you have ever had the opportunity to be inside a building with a higher performing window than, say, the typical brand windows that we see around here. But someone asked me a few months ago, a weird conversation about what favorite noises, or what noises that we love. And my answer was the sound of a really good window closing and then clicking locked, because it's like a barrier just goes up from outside to inside. So in places where the noise levels are really high, they make a tremendous difference. It's a weird thing to have as a favorite sound, but
I love it. I love it. And then not the kind of the non-code properties of windows, of course, we would be remiss if we didn't mention that, of course, our windows help us set the moods. It gives us visual clues. That helps us understand what the space is for, gives us a strong sense of connection to the outdoors, and it gives us a lot of, sense of well-being and beauty and natural daylight. One of the things, however, if you are designing a structure, whether it's residential or non-res, that has a lot of glass, like in this lead project, Obama Library, you can engage in glare analysis and glare studies. So next slide, Mike. Yeah, where you can take that building and model it in a 3-dimensional space and tell the software what the properties are of the glass, including those U factors, solar heat gain coefficients, visible light transmittance. And we can look at this and see how much visible light is coming through the glass and the quantity of glass and the angles throughout the year, and determine how much light would be inside that space and how much glare might be caused from that space. So in this particular project, we looked at a particular glazing assembly that had visible light transmittance of around 50%, which is pretty typical. But in this case, we are recommending visible light transmittance of 20%. I think we compromised around 30%, which is the 3 diagrams at the bottom. And the point is that you get lots of light with lots of glass, but too much light can be extremely uncomfortable for people's eyes. And so one of the ways then, for this particular project, the architect and the homeowner wanted to go with the 30% glass, as far as I recall. And then the next kind of layer on that is then you got to talk to about glare control in terms of solar shades and blinds. And next slide. That's now a whole nother 1 hour talk. That's what I could point out. Okay, Jennifer, that's a different TED Talk.
Yeah,
And there's
but they're
lots to
available.
choose
We'd
from.
love to see. We'd love to see people move towards exterior blinds. Interior are fairly easy, but if you're building something new, exterior blinds are fantastic options too. And there are a few companies. I think there's a company in Santa Barbara. There's definitely one or two in LA who are specializing in exterior blind systems. So a readily available option. I was just thinking too that we've, not to, a little side note here, we do have a pretty extensive video series on a lot of the things that we're talking about now that we worked on over the past 2 years. So I'm going to put a link to the Karen Collaborative YouTube channel, which Inbalance and Karen and Jennifer and I have worked together to make a series of videos around many of the things we're talking about today, including I think like a few videos on the windows and their installations, which we have a clip of one here, but I'll put a link to the whole channel through a passive house build.
And Mike, real quick.
Yep.
If you're not reading the comments, Judy Rachel's comment to everyone about condensation, I think is really is right on and appropriate. So maybe we'll kind of hit on the condensation thing a little bit too as we talk about triple pane glazing.
Cool. We have about 10 more slides left. So a few slides on frames and the different available options. And again, this is an every day is a school day type thing. Honestly, I talked to a manufacturer yesterday who's using it could just be a new name for a thing that already exists, but it's a new thing I've never heard of that their windows are being made out of. So it seems like every day some new technology is becoming available. But generally they were metal and non-metal frames. The metal were aluminum and steel, non-metal, wood, vinyl, fiberglass. Now there's Ultrex, there's a UPVC. Different manufacturers have a few different names now. There were your standard windows, which let heat transfer from the outside in and let cold transfer from the outside in, and vice versa. And then there were thermally broken windows, and it used to be just one kind that was thermally broken. Now thermally broken windows are available in almost every product. Even Home Depot carries thermally broken vinyl windows now. So the whole industry has caught on to the fact that windows have to break that thermal bridge. They're a huge part of the equation. Thermally broken metal frames have been around for a while. It's just using a gasket, and there are different types of gaskets and different kinds of scientific laboratory materials that get put into the frames. The end purpose is to just break the heat transfer, to break the thermal bridge that used to exist in our windows where the heat would just transfer from outside to in. So the example of living in a brand new apartment in San Luis Obispo on a 72-degree day outside, but because the sun's hitting that, the heat's transferring through and the inside of my window is 96 degrees, creating a radiator in September when I don't need a radiator inside a brand new building in September. So there's a gasket of some sort that breaks the heat transfer from outside to in or from inside to out. Wood-clad vinyl, UPVC is Zola's vinyl line. Fibrex is another material. I think Fibrex is Anderson or Marvin, but essentially you're trying to break these windows and get these much better R values by thermally breaking these windows. So we're just trying to let you know that you just have to ask, and these options are available. Plygem down here in the lower corner, that's Home Depot's line of windows. And Home Depot makes a thermally broken line of windows that's readily available at any one of their stores. So they're out there, you just have to ask for them. Was this one me? Oh,
Yeah.
okay. Sorry. My
Yeah, you take that one.
my trackpad broke, so I got like all flustered for a second. So this is actually a conversation I feel like I've had to, I mean, we're all in the industry. We've probably all been to therapy over clients, but I've had to battle clients to tell them that a casement window has a much greater effective open area than a slider or a double hung. And people just don't want to believe that that's the case. So we tend to use casements as much as we possibly can, and usually couple them with a large piece of fixed glass as well to get the ventilation effect. Select operability for purpose. The architects in the room are probably just shaking their heads, of course, but this is a little video clip. I think it's just a minute or two, a couple minutes long. Obviously, this lot was purchased for the views of Cerro San Luis, and there's a large landscape patio out there. So the clients wanted to have this pass-through system, but we had to have a really good pass-through system because this is a 15-foot wide, 9-foot tall, basically magnifying glass on the south-facing side of the house. So this is a triple pane folding window. Folding door system from Zola that we installed, but this video is a quick little clip about some of the work we've done with the windows.
So as we were just talking about the differences between fixed and operational units and why we've used a lot of fixed windows in this house and not very many operational units, but we've also used combos. So this is a really important spot for us to have glass. They're going to have a really beautiful garden right outside this window, but this is also a good spot for us to have ventilation. It's on the north side of the house and it's also their laundry room. So this larger unit here is a fixed pane of glass, and then we just have a small operational unit, and if you tilt it in, so it can be open for ventilation, and then you can close it, and the whole thing can be opened fully over the top of the laundry room countertop.
Just paying attention to what the true intention of the glazing area is meant for. So we use large fixed panels to let the daylight in, and then a not so large casement window, because the casement section would be a lower performing section of the window than the fixed panel. But that's the amount of ventilation that we need.
Well, as we
sorry. We're almost wrapping up here.
Oh yeah, and then as we, we're talking about windows, and Mike mentioned triple paned windows, and I had mentioned low-E coatings before. I think if you're architects, engineers, builders, you've by now heard of low-E coated windows. I'll hit on that briefly after the slide, because I do get a lot of questions asking, well, which surface should the glass be coated on? And mostly what I'm going to say is you want to work with your energy consultant to choose the U values and the solar heat gain coefficient that gives your project what you need. This little diagram is just to show two panes of glass, and you're going to see this in the literature, how the panes of glass are numbered, and the number 1 surface is the very outside, the number 4 surface is the very inside of this 4 surface, 2 panes of glass, and then the coatings are typically on the number 2 or number 3 surface. So depending on the coating, what type, where it is, it's going to affect the properties of the glass. Okay, and so next picture. And for climates, for example, that you want, like climate zone 5, sometimes we want a particular glass that actually allows heat to come through all the pieces of glass from the outside, and then once the heat is inside, we want it to basically have that low E coating reflect the heat back into the interiors to keep it warm. And that was pretty typical for dual paned glass assemblies for heating climates. Now, what we've got is all kinds of options for triple pane glazings and a variety of surfaces that can be coated. So now with the triple pane glass options, we can get a very, very low U value, which means high R value. So it doesn't act so much like a big hole in the wall anymore. And we can have these low E coatings put on certain surfaces so that we can reject unwanted heat from the exterior, which does stop heat from coming in the winter as well. But because the unit itself is so insulated and we can reflect heat back to the interior with our other low E coatings, the overall effect is that we still get a lot of visible light transfer through the window. So the window really looks good to us with our eyes, but it insulates better and it doesn't let the house overheat in the summer, and it still helps the house retain its heat in the winter. So we're finding kind of the best of both worlds with a lot of triple paned units. And then probably the next question we get asked all the time is, yeah, that sounds great, but how much does it cost? So, Mike.
Yeah. I don't want to say it always comes down to cost, but it seems to be that, I don't know, maybe it's just a fallback that everybody can relate to. We're not trying to, it doesn't do any good for us to encourage, high-end products being used in just single family homes. I was in a workshop a couple weeks ago, and one of the speakers, actually not a speaker, someone who was attending, said, we can't expect ourselves to single family custom residential our way out of the situations we've put ourselves in. So we don't want to do anything, and we don't want to build anything that is only catering to a certain clientele that's not, it can't be scaled across a larger clientele. So we priced out a dozen window packages. This is the Bishop Passive House here, and so we priced out a dozen window packages just for comparison, for our own workshop purposes and for the clients. And it came out to about 7%, a little less than 7% of the total house budget, not the total project budget, but the total house budget for the window and door package. And that includes all of the windows and all of the exterior doors, entry doors, everything except for the garage door. And this had two very high-end windows, that sliding folding door. Those are, whoever you get them from, are 15 to 23,000, depending on who they're coming from. So that alone carries a big percentage of that 7%. But these are really, really good windows coming in at a huge important factor to the comfort of the home, coming in at a fairly reasonable percentage of the cost of the project. Side note, given shipping constraints right now, that number from this particular manufacturer would be higher. It'd probably be about 9 or 10%. However, there are American, and it would probably take about 8 months to get them. There are American manufacturers making very good windows where the number would actually come in lower than that 7% right now, and they're readily available in 12 to 14 weeks, which used to be a long time, but today is actually pretty decent.
Yeah, there's, as we kind of wrap this up, I wanted to point out that there are some specialty glazing products coming on the market, and there's one of these, which I thought was just super interesting, is a product where they're looking at sending some of that sun's energy into photovoltaic cells into the frame, so that the whole thinking behind this idea is that if this surface, if your windows are going to be receiving all this sunlight energy anyway, how about we take some of that energy and get some electric energy from it by using the PV photovoltaic technology. And so I thought this was really intriguing. Go to the website and learn more about what they're doing. And then something that has been around for a while that we sometimes see in our projects, but often get value engineered out, is manufactured dynamic glazing, where the glazing actually changes. With this particular product, before Mike switches, they are making an interesting combination in more tropical climates, where some of the energy that comes through this glass powers a fan that is part of the like curtain wall assembly just below the window. So when that electricity hits and the temperature goes up, then that fan pulls in natural, it pulls in outside air directly and provide some cooling and natural ventilation. So I thought that whole combination is really intriguing for a lot of climate zones. Okay, so the manufactured electrochromatic glazing, Sage glass is the one that I know about that's probably the most popular or well known for this type of glass. It seems like you could get it in white or like the smoke. It seems like it has some great applications. It blocks a lot of the light. So in our areas, our Tri-County areas, we haven't seen too much of it, but I wanted to point that out so that you guys can take a look at it and find out more about this glass and potentially use it. But it uses that a little bit of electricity goes into a coating on the back side of the glass. And when that electricity runs through the coating, it turns the coating opaque. And therefore it either blocks out even more unwanted heat gain, which would contribute to more electricity, use because of air conditioning loads. And its overall effect can save energy and save money for the clients by affecting the glass. And then other times you could buy like field applied, next slide, third party elements that can be used just for privacy and just as a beautiful way to allow the glass to go opaque or to stay clear. So that's another brand that you might not be familiar with that you can look up. So when we take a look at our windows, yes, we definitely, as designers, architects, builders, we're looking at the view, the aesthetics, have to pay attention to fire egress, all that. But we want to take the intent of that, including our energy performance and sound control, and look at the strategy we want to use for it, which includes like, what type of operation does the window need to have? Is it for egress? Is it strictly for ventilation? Like the windows that Mike showed us in the video, do we really need a way to ventilate the space, but still keep the window more or less closed so that maybe our cats aren't jumping in and out of the window? That's what comes to mind when I see that, how to vent the laundry room, but keep the cat from going in and out. We've got to look at the frame type, the quantity, placement, et cetera. And then of course we get to the manufacturers and the fabricators and what product lines are available. I think we've probably got some questions in the chat that have to do with cost.
Yeah, I've actually, there's some great questions, so we can take a second to go through these. Steve, man, thanks for answering Tim's question. That was one of the ones that I was going to hop on. NFRC certification is voluntary for manufacturers. Steve and I have gone down rabbit holes with window manufacturers to get some of those things for projects. But Steve is a wealth of information for anybody that is looking for things. Judy has a couple questions. Daryl asked me a question directly, and I was going to answer it to the group. He asked, what about the other, this is in pertaining to this graph, which of course out of 45, 50 slides, this pie chart always gets a lot of attention, but this is how we break down our job costs. What about the other package percentages? So I can't even remember the 12 manufacturers that we priced out because it was a year and a half ago now, but we did do, we went Marvin, Anderson, Pella, Sierra Pacific, Zola, Wythe, Matthews Brothers, Alpin, Geldwin. I can't remember who else we looked at. So we ran the gamut on all of these. This particular product, and I think Judy, this will also answer some of your question where you said it's only 6.9% of the project cost, but really the window door package is one of the most expensive parts of the total build. It's also one of the most important parts of the total build. It's covering the holes in your building. Walls are fairly inexpensive to build, and then you have to fill in these huge gaping holes that you have with something. So total project cost for the effect that windows bring to a building, I think this is fairly good. That said, this could have been lower. This particular product line was chosen by the client, and we presented a UPVC package. They didn't want PVC windows. That was their choice, so they upcharged for an aluminum clad window. They liked these windows, and this was the only manufacturer where we could get, the clients had 9-foot tall, a 9-foot tall door in the back and 9-foot tall entry doors as well. And this was the only manufacturer who could make the entire package, all aluminum clad, all the same color, exterior and interior, for a price that worked for us, for a price point that worked for us. That's why we ended up at that number. It could have been lower if we'd used Simpson entry doors or Geldwin entry doors in a UPVC line from Zola or a vinyl clad line from Alpin. But the clients chose this particular line. So we probably could have had that number down to, I don't know, 5%. So I will say, I'll tell you actually, for transparency, the whole window and door package, including all the folding doors and entry doors and a very high-end folding banquet window that sits above a bathtub so the clients can look out over their garden side view, that total package came in around $70,000 imported from Europe. Marvin and Anderson, giving us similar values, were close to 90,000. Sierra Pacific came in at like 125 grand. So at the time, pre-pandemic, those numbers worked. Right now, windows coming from Europe are fairly expensive, so those other the American manufacturers have better price points. We're going to use Alpins on a not passive house, but close to passive house build in the next couple months, actually, because the price point worked. So I don't know if that answered your questions directly, but it's not just a black and white answer. But hopefully that helped.
Pre-pandemic, just kind of on average, would say, well, count on the windows being about 10% of your construction budget. We just kind of placeholder number. I don't know if that, it gave wiggle room.
They also chose this particular cladding, not so much part of the workshop, but Zola has different levels of claddings that you can pick, different colors. And of course, for those who have worked with custom residential, it's rare that clients make a choice that is that brings the cost down. So of course they fell in love with a color that was in the special price section. So they picked the highest end color they could have picked as well. So there were choices that could have been made to bring them in lower, and they made the choices that brought it in a little bit higher. But that's custom residential. So.
And sorry. Oh gosh, we can, if folks have questions too, they can, I think our group is small enough, we can unmute yourselves and ask questions. Feel free to do that. And we were gonna hit back on the condensation question, I think, and I forgot to mention it when we were talking about the triple paned glazed units. And someone in the chat had mentioned something else also about what kind of gas is in between the panes of glass and the purpose. And so, I mean, a lot of the panes of glass, your manufacturer would call it out as air. But a lot of the lower U factor windows would have argon, and there's some xenon gas that's even better. And the whole purpose of that is it just resists the heat transfer through those panes of glass into that air gap, through the next pane of glass into the air gap. So it improves the performance. In the past, I think what I have noticed is that the window manufacturers have gotten better at making windows that are, the frames are more thermally stable. So what I used to see with some of these frames come out is, especially on west facades on the Central Coast, is that the frames themselves would overheat a bit, and then the windows would, or the houses would shift, and then you'd get some racking, and then that gas would leak out. So the thinking was, but this is like 20-year-old thinking, the thinking was, oh, don't get those better windows because the gas is going to leak out anyway. It won't make a difference. Well, yeah, you should get the best windows you can afford, in my opinion, and the windows themselves. I've noticed the frames are so much more stable with these other materials that I haven't seen so much of that performance failure like that, where the frames are racking. And it does have some, to do with how the windows are installed and following the manufacturer's installation instructions, so that your window won't rack if you have a little bit of movement in your house, which you will, because nothing in construction is perfectly rigid. You want some, there has to be some built-in flexibility.
Judy asked a question too about how we can get windows like this to, I can't see the chat anymore, but I think it was something along the lines of our average clients, and not our high-end not high-end residential clients. The Bishop Passive House wasn't like an open budget kind of project. They chose to spend some money on the glass and some options that they wanted. But again, not brand specific, but Alpine makes really great windows. They're doing some pretty incredible things with their glass technology, and they're made in Colorado, and their pricing is very, very competitive with your normal everyday windows that you see in California. There are options out there, I guess, is what we're trying to say. So, like a car, you can buy a Bentley or you can buy a Prius. They're all out there. Well, none of us can buy Bentleys, but
right.
Some of our clients can.
We're one of the multifamily affordable housing projects I'm working on. This whole idea of budget and costs, and what we're noticing is that for certain climate zones, compliance with Title 24 is driving some of these discussions on the windows, because we have many builders and developers who do not want to follow the prescriptive walls and have exterior rigid insulation over the entire structure. So to mitigate for that, they've had to go to better windows. And those better windows have, the U factor, the solar heat gain coefficient, that whole combination is really pointed them in the direction of triple pane windows. And so, yeah, the cost goes up a little bit on the triple pane window, but the overall package for the cost of the affordable housing project is that they didn't have to clad the building with foam or Gutex or other, rigid, rock wool, other rigid exterior insulation. So they think they've saved some money that way, but now they've got better windows. And so that's kind of what we're seeing for Climate Zone 5. Climate Zone 5 is a little tricky because, well, 1 and 3, if you guys are from those climate zones too, you'll have similar situations where solar heat gain coefficient isn't really dictated. So it really depends on orientation, the intent. Is the project owner including air conditioning or not? So that was something when they went with a really high solar heat gain coefficient window, then it became really critical that the developer include air conditioning for their tenants. And they were trying to avoid that cost. And then they go too low on solar heat gain coefficient. And now we're back to the house not complying. Problem. So anyhow, work with your energy consultant, and I'm going to let Itzel finish.
Yeah. I put the link to the YouTube channel that has a lot of our install procedures. In the Inbalance and Karen have made the videos collaboratively. So Jennifer and I have worked on all of those together. If you want to, I think there's a dozen 4 or 5 minute videos that have been put together on different aspects. So feel free to peruse that in your spare time and shoot us an email or something if you have questions about it, or leave comments on the pages. I don't really know how that works, but go ahead, Itzel, close it up.
Yeah, thank you so much, Jennifer and Mike. I'm about to launch a poll. If you could kindly take this all information through this poll, is super insightful to help out and, you know, just see what kind of trainings we could continue to offer to our region. So thank you so much for taking time to take that. A little bit of information. So there are continuing AIA units available. We have 1.25 health and safety and welfare units. So for those who submitted their AIA number, I'll be getting back to you with that. But also, if you have any questions about that, feel free to email me directly. I'll drop my email there. Coming to you soon are slides, recording, and an additional survey where you could put it written in responses about like trainings you're looking forward to seeing in the region. All that information is super helpful. And some upcoming courses to look out to for our winter calendar are listed in our agenda here in our slide, but I'll also drop our website calendar directly to see if any of you are interested in registering. But thank you so much for joining in today. I hope all of you found this super helpful and insightful, and looking forward to seeing new and familiar faces in our next trainings. And if there's any more questions for Jennifer, Mike, or I, feel free to ask. Thank you so much.
I have one quick thing to say. So this is, I'm like, now I've got the chat open again, and I never pay attention to the chat, but there are some people that are in these workshops who are really pretty incredible people in this field. I mean, Chie's written a book about the retrofit that she did herself. She's an amazing person. Midori House is her book. Like, you should get that book and read that book. Steve Mann is a wealth of knowledge, and I mean, he's like a Jennifer to me, like a Jennifer. I mean, he's just a brilliant guy. Trevor Miller keeps coming to these workshops, and he's got a strong foot in the industry here in SLO. So it's really cool to see people showing up to these things, because we've been doing it for 3 years. And
yep, and Judy Rachel's on this call.
Yeah, Judy, those questions are awesome. And sometimes Jennifer and I are just like, oh, are people showing up? Do people care? Like, we really care a lot. So we put a lot of time into it outside of our jobs. You know, I didn't leave the office till 11 o'clock last night. So it's really great to see people showing up and saying thank you, and to know that we're not alone out there. It's nice to, it's cool to see everyone. So thanks for all the awesome people being here. Yeah.
And hopefully for those folks and our friends and colleagues who also do a lot of this work, hopefully there's some images and things we said that can just help you help your clients. That's the thing I realize, is that all of us together can help each other kind of get the word out and bring everybody up to speed and improve what we do. So yeah, thanks. You guys, the folks who are putting all those thank yous and stuff in the comments, that's super sweet. Yay. Thank you.
Yeah. All right, I'm gonna log off. Thanks, everyone.
Alrighty, thank you everyone. Bye.